So taking a look at 8629, it says refer to figures 56, 57, and 58. What is the ground distance covered during en route climb for operating conditions V2? So figure 56 is going to give us those operating conditions, and we'll just go ahead and highlight V2. Now we know that what we're working with, we need to decide what chart we're going to use, figure 57 or figure 58. And the big difference between these is that they are based on different ISA temperatures. Figure 58 is ISA plus 10, while figure 57 is ISA exactly. When we look at our operating conditions, we can see that we're going to be using ISA exactly, so we're going to focus on figure 57. Looking at figure 57, we can see that we need a brake release weight and we need a pressure altitude. So our operating conditions say that our brake release weight is 95,000. We're going to be using this column. And our pressure altitude is 27,000 feet, so we're going to be using this row. And we're just going to bring those together until we find the box where they meet up. So we're going to be using this box here. If you look up in the top left, it tells you how this is measured. So it's time, then fuel, then distance, and true airspeed. So before we consider our wind, which is the thing we're going to be correcting for in this problem, we can go ahead and write down all of these factors. And I would get a scratch piece of paper for this. So our no wind time is 13 minutes. And then the fuel is not our worry right now. We're not calculating for fuel. So we can move on to distance. Our no wind distance is 65 knots. No wind distance is 65. And then our true airspeed, it says is 356, but for these problems, we're going to disregard that, and we're actually going to have to calculate our own airspeed. So in order to do that, we need to know about the distance, time, and speed graph. So let's take a little sidebar over here. To get distance, time, and speed, you can think of it as a big triangle. So I would maybe make a note of this as well. Distance is going to be on the top, and then you're going to have speed and time. To solve for, let's say, speed, we'll write that up here. To solve for speed, that's going to be distance divided by time. So you can see exactly it's distance divided by time. If you draw it as a little triangle, you can kind of see exactly what you should be doing. If we want to solve for distance, then we would take speed times time. Speed times time. It's hard for me to say. And for time, we would take distance divided by speed. So you might just want to make a note of that. Now, again, we need to figure out right now our speed. So we're focusing on this first. So we know that our speed is going to be distance divided by time. So we're going to take 65 and we're going to divide that by 13. And that will give us, if we go ahead and pull up a calculator here, 65 divided by 13 equals 5. But you need to multiply this by 60 because we need to know what we're going per hour. So our no wind speed equals 60 times 5, which is going to be 300 knots. So now that we have our no wind speed, we can account for our wind component up here, which is a 20 knot tailwind. Remember that a 20 knot tailwind is going to make you faster. So we're going to add in 20 knots. So our wind true airspeed equals 320 knots. So remember that we're solving for our distance covered. So we need to figure out how fast we're moving and then how fast we're going to cover that ground in 13 minutes. So to figure that out, our distance equals speed times time. So what we're going to do here is you can do this two ways. You can take 320, multiply it by 16, or 13, excuse me, and then you can divide that by 60. So 320 times 13 divided by 60. So 320 times 13, and that is divided by 60. That's going to give us 69.3 repeating. What you can also do is you can take 320 and divide that by 60. So 320 divided by 60, and then you can multiply that by 13. So 320 divided by 60 times 13, and that'll give you the same number, 69.3 repeating. And what you're doing here essentially is you're taking your speed, that 320, dividing it by 60 to get your speed per minute, and then you're multiplying that by the minute that was given to you, or the amount of time that was given to you in the problem. So now that we've got 69.3, we're coming over and looking at our answers, and our answer is going to be 69 nautical miles. As long as you remember this chart over here, all of these questions should be relatively simple. So make sure that you make a note of that distance, time, speed chart.